All right, next part is the x-intercept. Where is the graph going to cross the x-axis? Okay, so what you want to do is you want to set the numerator equal to 0 and solve. All right, so here we are at number 1. I want to take my numerator. I want to take it from my simplified version. So right now my numerator is 1. So I'm going to take 1 and I'm going to set it equal to 0. Now this is actually a trickier problem for the x-intercept. So I took my numerator, which was 1. I set it equal to 0. Now does 1 equal 0? No. Okay, so this is a false statement. If a false statement is created, then the x-intercept is going to be none. So it's never actually going to touch the x-intercept. I know that's a little bit of a confusing one. You can come back to that one later if you need to. Okay, an easier one. For B, all you're going to do is you set the numerator equal to 0. So x minus 5 equals 0. And then I'm going to solve that. So how do you solve? I want to get x by itself. So I would add 5 to both sides. X equals 5. So that means that my x-intercept is going to be at 5. Since the x-intercept is a point, I'm going to write 5 as a coordinate point. So I'm going to write 5, 0. Okay. Part C. Okay. X-intercept. I'm going to set my numerator equal to 0. X plus 1 equals 0. I want to solve it, so I would subtract 1 from each side. X equals negative 1, and then I write that as a coordinate point, negative 1, 0. Okay, if you want to go ahead and try the U-try problem, just hit pause. So now, here's my numerators 1. 1 equals 0. 1 does not equal 0. That is a false statement, which means that the x-intercept is going to be none. So pretty much anytime you just have a number in the numerator, you're never going to have an x-intercept, which is okay. It's allowed to not touch the x-axis. So again, for x-intercept, all you do is you set the numerator equal to 0 and solve. Okay? If the numerator is a number, then that means it's none, just like we had in part A in the U-try problem.